The purpose of this video is to review the software we have developed for reconstructing 3D point clouds from a series of stereopair images. It should be noted that the user is required to capture a series of stereopair images of a known checkerboard pattern to facilitate calibration. The software was written in C++ using the OpenCV and PCL libraries, while Qt was used to generate the graphical user interface. On the left side of the interface is a tree view structure to highlight the input images, the output point clouds, as well as some intermediate results. Moving to the right, a display area facilitates visualization of the left and right stereopair images, and the panel below contains the series of actions and options necessary to perform the point cloud reconstruction. The first step for point cloud reconstruction involves collection of the input images. Clicking the stereo capture button invokes a panel to facilitate capturing stereopair images and video streams. For reference, it is desirable to capture 12 or more pairs of checkerboard images to generate an accurate calibration of the stereopair setup. Note that the number of corners and edge size of the checkerboard image used for calibration must be specified. To review the reconstruction process, we use a sample series of checkerboard and phantom images captured previously. The first step involves extracting the locations of the corners in the checkerboard images, which is performed via clicking the Extract Corners button. A series of output images highlighting the locations of the detected corners are generated and can be reviewed via the Tree View interface at the left under the Corners heading. After corners are extracted, we can calibrate the stereo camera by clicking the Calibrate button. The output matrices and error metrics can be reviewed via the tree panel under the matrices heading. In short, the average epiline error and the projection error will provide the user with an indication of the quality of the calibration. The next step in the reconstruction process involves computing the disparity images for the series of stereopair images of the target object. The output disparity images can be reviewed via the tree view panel to the left under the disparity heading. In the event that any one of the disparity images reveal a suboptimal output, additional functionality invoked via the Tune Disparity button allows the user to modify parameters associated with the disparity computation to improve the result. Once the disparity image computation is deemed acceptable, we can reconstruct the point clouds for each disparity image using the button labeled Reconstruct. After computing the reconstruction, the Display PCL panel is invoked that immediately provides a visualization of the point clouds, and all of the reconstructed point clouds are saved under the point cloud heading in the Tree View panel.